Hi, in this video we'll be looking at how to make a super cheap IoT thing using ESP8266 developer kit, which is a super cheap, probably available for between $3 and $5 in many places. Connecting that to AWS IoT Core, from there sending that data to AWS Lambda where it's processed, and sending that further to S3 where it's stored. And similarly in S3 we have a simple HTML and JavaScript app which is capable of taking the data and showing a beautiful chart, right? Let's move on. But before you start, there are certain things that you need to get ready with. So here, for this particular project, you need to have an account with AWS, right? With AWS IoT signed up for. Here, this is very important because we'll be using various features of AWS IoT, the MQTT feature where we will be sending the data. So we'll be needing AWS IoT enabled in your account. And you need to install the AWS command line and set it up properly so that it works. My recommended way would be to actually create an IAM user in AWS, right? Set up that user so that the particular user has permissions to manage AWS IoT, right? And then ensure that the setup works properly, right? Moving on the device side, we'll be using the ESP8266 developer kit. Sometimes you will find these under Node MCU. Node MCU is actually the software distribution, but in general you will find many of these kits calling themselves Node MCU, right? Many vendors will be selling them under this name. But one thing to note here is that the serial chip driver needs to be installed on your computer for this to work. For example, in this particular picture, we can see that this chip is a Scilab's chip. This is a very popular chip, right? And this is the chip you will typically find near the USB connector, which also acts as a serial port for us, right? So in this case, it's a Scilab chip. And sometimes you can also find that the driver name is written behind the board itself. For example, you can see here that it says install CP2002 driver, which means that it has the CP2002 serial chip, right? Similarly, there's other popular serial chips, in this case a CH340G and similar. It really depends. So you get your board, figure out what serial chip it has, and ensure that you are able to communicate with it, right? We will be using the very capable Mongoose operating system. It's completely open source, and it's great not only for this project but for many other projects. But the really cool thing is that Mongoose OS makes it very trivial for us to set up a device and communicate with AWS IoT Core. In this particular video, I'll be using the C programming language to program the ESP8266, but JavaScript is also perfectly usable in this particular use case. We will possibly see if there is enough interest. I'll see if I can repeat this video in JavaScript, right? So here are the popular drivers. They're also listing, right? So you take a look at this, right? And finally, our output will be in this form, right? All the source code for the instructions are available in the companion article. Please check it out. You will need to know a little bit of HTML, but yeah, that's okay if you don't know, because you can always follow along my HTML. It's dead simply source code, the HTML source code, right? Pretty much that's it, the whole thing, right? So you should be able to manage. It's a little bit of JavaScript, right? It's just pulling the file which we store in S3 and then taking it forward from there, right? So let's jump right ahead into the video with more details. The ESP8266 based boards that we see in the market today, especially the boards compatible with Node MCU, are actually available for costs as low as $3 in the market. And you can power these off battery packs because they're powered through a micro USB cable and with a 5-volt standard USB input. In spite of their cost, these have quite a bit of RAM and CPU to handle the encryption required by platforms like AWS IoT Core. And you can also connect a lot of peripherals, because they have quite a bit of GPIO pins and other communication peripherals you can take advantage of. Here we'll see how to take one such board, the Node MCU, which is powered by ESP8266, and connected to AWS IoT Core. But the thing is that we want to measure something. So what we'll do is we'll connect this to temperature and humidity sensor, a very popular one called DHT11, and we will send this data to AWS IoT Core, and there we'll process this data using AWS Lambda, and then store this in S3. And in S3 as well, we will keep a public facing web page which will display our temperature and humidity. This is the page that we will be developing, right? So we'll store temperature there for 24 hours, right? We will measure, we'll make one measurement of both temperature and humidity every 5 minutes, and we will store it there, right? To make things easy, we will be using the Mongoose operating system, which will be running on our IoT device here with the ESP8266, right? And like I said, we won't be using any servers. We'll directly be using, we'll leverage AWS S3 to essentially be our server or service, right? So let's get started. This is a fairly exciting and also very easy project to do. For this particular web page, we will be using chart.js to show that we make it easy for ourselves to plot all these things, and it's a beautiful library which is fairly easy to use as well, right? Let's get started. First is we'll take a look at the device side of things, because we'll be using Mongoose OS. Let's start with cloning an empty project, and then we'll take it from there. Let's clone a project now. Let's open up mos.yml. This is the configuration file for this particular project, the Mongoose OS configuration file, and we'll add all the libraries necessary to do our business. Okay, let's go down here. We need a bunch of libraries. These are the ones we will need. Now you should check out the companion article which I have linked in the video description below. You will be able to see all the required code, the configuration files and all of that, so you don't have to worry about copying anything directly off the video. Okay, so these are all the libraries that we will be requiring as far as Mongoose OS is concerned. Let's edit source main, which is the main source code file. We'll be needing MQTT and DHT support. MQTT is the protocol we'll be using. Excuse me, MQTT is the protocol we'll be using to communicate between the device, the ESP8266, and the AWS IoT Core servers. It's a very common protocol, and if you continue to learn anything related to IoT, you will see that MQTT is a very, very common protocol. It's a very simple protocol which devices with constrained memory and CPU can handle very easily, right? And it's a very lightweight protocol. Let's add, we'll be connecting to Wi-Fi. So we'll add a bunch of, we'll add a callback which will tell us if our Wi-Fi connection was successful and all of that. This will take care of that. Now let's blink an LED, right, every 1 second. Okay, and what we're doing is that we are setting our GPIO to output mode, so that we can control output, or we're not reading anything. We are actually trying to set from the chip outside, right? We are trying to blink the LED from the chip to outside. Now if the same thing were a switch, we are trying to read from outside to the chip, so that will be an input mode, but in this case it's an output mode, right? So every 1 second, which is 1000 milliseconds, right? And we are repeating, so it's not a one-off timer, we repeat this timer. So we'll have to call this function. We are asking the operating system to call this function, right? So that we can blink a LED every 1 second. Now this function is right here. Okay, here we log, right? And let's uncomment this. In this timer callback, we are simply toggling GPIO pin number 2, which is a built-in LED on the board, right? Now you have to understand the Node MCU and other related development boards, which are based on the ESP8266, have an LED, have a serial chip, right? So that it becomes easy for anyone to develop, using the ESP8266, right? The ESP8266 is just the core, and we have, certain things around this. For example, we have various headers for GPIO. There's a serial port so that we can program the chip, so that we can use it as a real, serial chip, and things like that, right? So let's now try and compile and flash this, so that we can see if this code we have here is working. So as you can see, this code really does nothing, doesn't do a lot. So we are setting up a handler for network events, and as you can see here, the net CB, or the net callback, will be called, and then the event will be passed, and based on this event we know what's happening, whether the internet is connected, whether the net is not connected, and stuff like that. It's not the internet, rather it's the network, the Wi-Fi network, right? That's the first callback we have, we have here. Now the second callback which we have here is the LED timer callback, which is basically a timer which gets fired every 1 second continuously, repeat mode. And here we are basically toggling GPIO pin number 2, in which there is an LED connected, right? And then what we are doing is that we are simply printing some information every 1 second on the serial console, which we can also see, right? Let's save this file, open a new tab. Okay, now we are in the right folder. Let's build our project. It's complaining about val. Let me go and figure out. Okay, we don't need this here. That was because I removed the comment from earlier. Let's clear the screen, build it once more. Perfect. Now we have the firmware ready. We'll flash it. As you can see, the LED is blinking on the ESP8266. It's kind of faint. I hope you're able to see it. It's done. And now you can see that the LED is flashing every 1 second, which means our program is running, right? Now, this is step 1, right? Let's take this to step 2, where we could connect it to Wi-Fi, right? And we could also do something. For example, there is a button also available on this ESP8266 board, which on clicking we could send a message onto AWS, for example, right? Because we don't want to wait for 5 minutes, or we don't want to send a lot of messages onto AWS. So we can easily test this when and when we want, right? So let's go ahead and move to the next step now. Now let's set up one more callback when the button is pressed, right? Okay, so on GPIO 0, we call button CB, right, whenever that particular button is pressed. Okay, let's now define button CB here. We'll comment this out for now. We don't have this function defined yet, but we're gonna do that very soon. Okay, now here what essentially we're doing is that we'll be getting the temperature and humidity from this connected DHT11 module. Okay, we'll also initialize it. Let's initialize the DHT11 module right here. Okay, so we are creating DHT okay, we need this variable set up globally. Let's do that all the way up. I'll put this here somewhere. Okay, it's a structure that has the DHT structure defined by Mongoose OS, and DHT11 is supported directly by Mongoose OS, right? So we simply use the functions and the structure provided by Mongoose OS. Okay, so let's do this again. We initialize DHT11 right here. Okay, and and we have set up a callback on a button press. In the callback, we read the temperature and the humidity and we print it in the console. Okay, that's what we're gonna do. And by the way, we're already printing to the console. Remember, we are printing uptime and a bunch of things from here, from this callback. Now, to observe what's being printed in the console is fairly easy. You simply do MOS console. Okay, you're able to see the messages right now. Now that we have the code modified on button press, we are reading the temperature. Let's try that. For this, we have to build again. Hopefully everything is okay. Perfect, we have a successful build. I'll clear the screen and let's flash. You can see the LED rapidly blinking. I don't know if the camera is picking it up. If you're done, and you can see that the LED has gone back to the 1 second, which means our code is running. Now, let me open the, let me run the console command so that you can see that you can see the callback printing uptime. Now, if I press the little button here near the USB connector, it should actually print the temperature and the humidity. Let's try that now. Perfect. So we're getting 28 degrees and a humidity of 38. It's actually a lot warmer because I'm in Chennai, India, but I have the air conditioner on, so you can see the temperature is 28 degrees and humidity is fairly low at 38. Okay, so we can call that a success. Now, the idea is to report this temperature and humidity every 5 minutes, right, to Amazon IoT Core, AWS IoT Core. then do some basic processing there, right? And then keep it in a JSON file on S3. At the same time, have a very simple HTML file which uses chart.js to pick up the JSON file, information from that JSON file, and show the temperature and humidity charted. Okay. Now let's move on to the next step. Let me get out of this console. You just type Control C. Okay, so let me give you a tour of, let's close this. So this is the AWS IoT console. Okay, now if you go to manage, you should be able to find devices here. We don't find anything here because we haven't really registered a device or anything. The good thing about Mongoose OS is that it makes it really easy for us to register devices, right? And control them, right? So let's try and see how that works, right? We're gonna report some stuff to AWS from our device, which we just set up, okay? Temperature and humidity. Let's go ahead and do that. Now, if you have all your the AWS CLI configured properly, you should be able to run this command. Let me clear the screen. Okay, MOS AWS-IoT-setup. So this provisions a new device, also provisions the required certificate and key for the particular device, and it'll add it to the existing the project that we are in, the workspace that we are in, right? Now let's try that. Perfect. Now it says saving and rebooting. So what it's done is also talk to the device and copied the necessary files required for this device to work with AWS IoT. Okay. Now we have the certificate and the key files, right? The reason why this is required is that AWS doesn't allow random devices to communicate with its IoT infrastructure. Number one, the device should send encrypted information. The device should be able to authenticate and identify itself, right? Now for this you have to do something called provisioning, right? Now provisioning meaning you will have to talk to the AWS API and create and provision a device, and then you will get a key and certificate, right? And all this is made really easy by for us because we're using the Mongoose OS system, right? So this is what is happening here. Now this device is completely provisioned, right? In the console, in the AWS console. We could check it out here. We should be able to see our device. There we are. Now you are able to see this 4038B7, right? That's typically the last three bytes from the ESP8266's MAC ID. Okay, you can if you have more than one ESP8266 and you want to see which one it is, you will be able to do this and see, right? This is the last 3 bytes of the MAC address. Okay, now let's go back here. Okay, now this device can talk to our the AWS console. So what we'll do is that make the temperature and humidity go to AWS. We'll report that to AWS right now. Okay, let's do that. I'll now add the report temperature function. Okay, it's a fairly easy function to understand. Now what we're doing here is that we have a 160 character message buffer for JSON, okay, because we're gonna report temperature as JSON. Okay, now we will be creating this topic called event /temp_humidity. Okay, and this will be the topic that we'll be writing to. Now let me change this event because I want this to be unique. Okay. All right. So here we'll show total RAM available, free RAM available, the temperature, the humidity, and which device this is coming from, right? And we'll get the device ID, which will basically be the MAC address usually, okay? And the timestamp as well in this particular format, okay? So we are having the hour, minute, and seconds, okay? All right, so we will, when this function is called, we will do mgos mqtt pub, which is we are publishing to this particular topic, this message, okay? That's all that's all this thing does. Now we're not calling this function from anywhere though. Now, what we will do is we will simply call this function whenever our button is pressed, okay, so that we can easily check. Now let's do exactly that. Of course, before that we'll have to compile and flash, right? Because you know, this is C and you have to compile. Let's build and hope everything goes well. Okay, we have success. Let's flash. Now, before we flash, I want to set up Wi-Fi. So what I'm doing here is I'm simply asking the MOS utility to configure Wi-Fi. This is the name of the Wi-Fi network I want to connect to, followed by the Wi-Fi password. That's done. Now we have the new firmware where we are reporting the temperature and humidity to AWS by publishing a MQTT message on button press, right? So we're gonna flash that, okay? All right. You can see the LED flashing very rapidly. Okay, let's get the console and see if we are able to connect to Wi-Fi. It's not connecting to Wi-Fi, which means that I might need to set up Wi-Fi again. Just a second. Okay, let's do that again. Set up my Wi-Fi. All right, let's see if it works now. It's trying to connect to, okay, perfect. Perfect. It's connected to the 80-wick network and it's got an IP address 167. That's great. Now let's see if we are able to send a message to Amazon by pressing this button here. Okay, it's reporting the temperature, but it's not publishing to Amazon. I know the reason. The reason is because we provisioned the device and then we flashed, meaning that it won't be able to, it would have overwritten the files on the device, right? So what I'm going to do is I'm going to reprovision this. So let's delete the device from Amazon here. Delete this. Yes, delete, sir. And we'll come back and we will reprovision. Okay, let's get a console. It's connected to Wi-Fi. It's actually even able to connect to Amazon. Okay, right here, I'm able to see that. Now let's see if I click on the button, if it's able to report the temperature or not. Okay, I'm seeing publish to MQTT, yes. Okay, right here. That's the main thing. Okay, so we're getting printing the temperature, and we are able to publish to MQTT. Now let's go to the Amazon console. Okay, refresh this. I should be able to see the thing here. There we go. Okay, now let's go and see if we can hash means all messages. Show me all messages. That's what I'm gonna do. I'm saying subscribe to this topic. I'm saying to the console, subscribe to this topic, show me any messages, any message from any device, right? That's exactly what I'm doing here. This is the MQTT client, right? I'm gonna press the button and you should see whatever we are sending from the device appear here. There we go. We're able to see total RAM, free RAM, temperature, humidity, and all of that, right? Okay, so we are good. We're halfway there, okay? And we need to take this message, publish it to basically Lambda, right? And take it from there, okay? Let's test this once more. All right, we got the temperature. Perfect. So this is the event, right? So let's copy this. We need to act on this event now, right? So we're gonna go here and we're gonna say create a rule, and we'll say store temp underscore humid underscore ESP8266 to S3. Okay, that's the name we'll give. Store all right. So we'll say or we'll simply say star here. Okay, that's right. We don't want a condition. Okay, so here we're just saying that I need all the attributes. All right, and then we are saying this is the topic. Okay, so this is constructing a SQL query from it, right? Which is a very good way of actually picking up events. Now you get events as JSON, and then you want certain events, and then you can give a you can give a for example, you can say temperature greater than 25 degrees. So it will only pick up events in which temperature is greater than 25, right? So I guess you get it, but we don't want this. We want everything. So this is the SQL statement now. This is not really SQL, but Amazon AWS is allowing us to use SQL to read attributes from our messages, from the JSON message you saw earlier, right? All right, so let's set an action on this. Okay, now we're gonna do Lambda, right? Lambda's right here. Configure the action, choose a resource. I already have a Lambda function, okay, named store temperature in S3, which we will use. We'll add action. Okay, all right, we'll create this rule. Now whenever we get a message, we should invoke this Lambda function, this particular action, okay, and it'll call this Lambda function. All right, now let's go to Lambda. I'm sorry, we have a Lambda function, our Lambda function here, which is written in Python. All right, so this is our Lambda function right here. What we do here is that I have a bucket name, and then I have a temp file in which I keep some JSON values. I'm defining max readings as basically 60 by 5, which is we have 60 minutes in an hour, and I'm storing readings every 5 minutes, right? Into 24, which is we wanna store these readings every 24 hours, right? And then we have, this is the max readings, okay? And then what we're doing is that this is the main Lambda handler that will get called, right? So let me see if I can increase the font size so that you guys can see this better. Okay, now that's definitely better. That's even better. All right. So printing event details. Okay. Getting the device from the device RJSON. Okay, and then we are calling get existing values, which will get the existing values, the JSON file which is stored in S3. Okay. Now we are appending the value that we got just now to the Lambda file, to the JSON file. I'm sorry. Okay, now the good thing is that AWS allows us to test this easily. Now how are we going to test it? Now look at here on the top, you can save some events. Okay, now we will configure test events. Okay, now I have this little test data here which resembles our data quite a bit, right? I've just copied one of the events and pasted it here. Okay, now let me test this. Now again, if you test this, seeing the output here. Okay, so request ID, and this is what the function is printing. Okay, and it's saying that this ran for 1300 milliseconds. Okay, and then they build me for 1400 milliseconds, and this is the kind of memory it used, the function. All right, so these are the values that are already there in the JSON file on S3. Let me close this. How do I close this? All right. Now in get existing values, what I'm doing is I'm using the Boto library, right? I have a dictionary defined here which has temperature readings, a list, humidity readings, another list, and timestamps, another list. Okay, now the idea is in this list I will keep temperature readings every 5 minutes for the past 24 hours. Okay, and every time I get a new message, I'll look at the list. If it's older than max readings, if it's larger than max readings, I'm sorry, we will remove the oldest value. Okay, that's exactly what we will do, so that this list is exactly maintained for the number of readings we want. Okay, and it doesn't grow out of control, right? That's exactly what we're doing. So we're using the we're downloading the file to a temporary file, right, which this lambda function can access. We're opening the file, we are loading the JSON value in existing values. Okay, and then essentially we are returning the existing values. Okay, now this is the function where the real magic happens. Now we get existing values. Okay, and then what we are doing is this is called here, so we say get existing values. Okay, now with this we are calling append values to S3 object. This is the device we get from the R event, right? We are sending the device ID there, and we are sending existing values which we got from get existing values, and the actual event itself. Okay, now here what we are doing is we're checking whether the length is reached, right? If it is, then we are actually removing, we are slicing, we're using a slicing operation on all these three lists. We have three lists, right? Temperature readings, humidity readings, and timestamps. Okay, then we are appending the value of the temperature and the humidity and the timestamp we got, and then we are pushing that JSON file onto S3, this particular bucket. Okay, simple function. If you're used to programming S3 using JavaScript or Python, you can use the Lambda function. You can use a Node-based Lambda function, Node.js Lambda function, or a Python Lambda function to essentially get your business done. Now, the great thing about this is that you don't have a server running. You're only charged, and I think there's 1,000,000 calls free or something, right? Which is great. Okay. So this is exactly what happens now. All right. So let's go ahead and see how this works. By the way, you in case that you want to check during runtime if something goes wrong, you can always look at the logs, right? And what happened, whether everything's working well. All right. So let's go back to our function. I want to see the logs for this. Yeah, you go to this tab, monitoring. Okay, it's right here all the time. I missed it. Okay, now you can see that recently we pressed the button and our function got called and all that. Okay, this must be from the test. Okay, now you can always go to jump to logs here, errors, right? Invocation errors. You can look at the log. AWS maintains a log for every call. All right, you have this right here. There you have. This is the log. All right. Now let's do something. Let's send an event. If you press a button, you should be able to. Our Lambda function should get invoked, right? Now let's refresh logs here. Okay, 608. 608. All right. We are able to see this here. All right, so the logs are taking a bit to arrive, but they are coming. Okay, 608:59. So we're getting it at 609. Of course, there's a little bit of temperature difference everywhere. Okay, so there we are. This is the last log. Let's try one more. Okay, there we have one more log. Okay, perfect. So everything is working well. We are able to see that our Lambda function is getting called. Okay, we saw how to test the Lambda function with test data, right? Which is very important during development. You want to see how it's executing in the Lambda environment. And finally, when the actual information is going to Lambda, we're seeing we are able to send. This is just a small technique to test. Now you don't want to wait every like 5 minutes, or you don't want to send a lot of data and get confused, right? So setting up a callback and sending the data allows you to, in a very controlled manner, test your Lambda environment, right, and see how things are working, right? Now finally, what we can do is we can enable our data to be published every 5 minutes, right? So let's do just that. It's very simple because we have everything in place now. Okay, all we're going to do is we are simply going to add this function in, right? Here what we're doing is that 300,000 is basically 300,000 milliseconds is basically 5 minutes. Okay, we are repeating this timer. We are calling report temperature, which will simply read our DHT11 sensor, which contains temperature and humidity, right? And it publishes that JSON information to MGOS MQTT publish, which we have already set up using Mongoose OS, set up using AWS IoT setup, right? It just publishes it to AWS. That's it. So once you have this, every 5 minutes, you will be able to see right here all the temperature readings and humidity readings here, right? So guys, hope you guys had a good time learning this. I had a lot of fun getting this up and running, right? And if you have any suggestions, please let me know in the comments, and also try to read the companion article. Now, you have to understand that you will have to set up the Mongoose OS compilation tool, and you have to set up the AWS CLI for this to work properly, right? And without that, this is not going to work. So those are topics on which you can get help easily on the internet, right? Mongoose OS tool is just a basic, you unzip the file and copy it to the right location. But AWS client setup is a little bit more involved, because you need to create a user which has the right permissions to be able to access. Now, similarly, your Lambda function also should be able to have access to S3, for example, right? Now, that is kind of out of scope for this video, but you should be able to get a lot more information on this fairly easily. That's why I thought it's okay to omit that, right? So you need to create AWS roles, and that role should be assigned to the Lambda function for it to work properly. So those are the thoughts that I'll leave you with. I hope to see you in my next video. Please subscribe to the channel and like the video. Thank you.